Okay, so I'm actually going to spend a little bit of time on this page with some very good reasons, so I need you to listen. For a lot of you, knowing the formulas can be painful. Now, to be honest, you'll be given most of these formulas in your exams, and in the HSC you actually get given these formulas. But what you need to be aware of is that any area of a quadrilateral is all based around the height and the base. So for example, in a parallelogram, we use base and height. But if you notice in this trapezium, they've got the H there, but they refer to A plus B. But the A plus B, in a sense, is still refers to the base. It's just that in this case, the base are two different lengths, so they add them together. In in rhombuses and kites, so these two here, you got half of the product of the diagonals. So you've actually got to times the diagonals together and halve them. But again, they talk about X and Y. But what you hopefully are noticing, and I'll just point this out to you, is every single time you are timesing anything together, it is the two values that are around the right angle. So here's my height, here's one of my dimensions, and in this case, these are the two dimensions that are right angles to the trapezium. Notice in the rhombus, even though we are dealing with diagonals, it's because the diagonals are at right angles. The kite, there's my diagonals. The diagonals meet at right angles. Okay, so every single area shape that you deal with is because you are looking at the dimensions that surround the right angle. Now I need you to think about this because it actually saves you having to remember a lot of formulas, and you can just sort of come up with other quick ways to remember it, because all you have to remember is you've got to times together the values around the right angle. Also, something to be aware of, sometimes you can actually be given a rhombus. Okay, so I'm just going to draw a very bad rhombus here. Let's pretend that all the sides are equal. But you actually may be given a rhombus, but they give you the height and the base instead of the diagonals, okay? So that base and that height, or those two dimensions which surround the right angle, because if I was to put those two together, I actually do get a right angle. In this case, we don't go half of the base times the height. It's the same as if you're doing a parallelogram. It just happens to be a parallelogram with all sides equal. So with a rhombus, if you are given the diagonals, okay, then you times them together and halve them. If you are given a rhombus, but they give you a base with its height, then you just times them together. You do not halve. I don't see a lot of this case, okay? Usually I see mostly this, but just in case, which always means it might be something we put in an exam. Okay, so very quickly, you look at it. Now, there's no right angle being given here, but that's what this length is, okay? It's perpendicular to the 14, which it forms a right angle, so I get area equals 9 times 14. And all I have to do is go 9 times 14, which is 126 square metres. Okay, so when we look at this shape, first of all, you hopefully recognise that it's a kite. Secondly, you hopefully recognise that you are dealing with diagonals at right angles. Okay, but all you need to realise is that the dimensions you are concerned with are the right angle, are the ones that meet at right angles. Okay, and then you just got to use the formula. You just need to remember that the formula is area equals half the product of the diagonals, so half times 9 times 14. Whoops, forgot to put the 14 first, which is what I usually like to do, but who cares, because I can now just go 7 times 9. Now the reason you need to be aware of these diagonals or right angles, because who's to say we won't give you a question that actually has these measurements here given, or have these measurements here given. Now we might give you all 4 measurements. How are you going to know which ones to use? And the trick will be to always look for the right angle. Also, on back to this parallelogram here on the left hand side, previously I'd said you got to look for the diagonal or the right angle. Notice with a parallelogram, okay, again, bad sketch, but if I use diagonals in a parallelogram, notice how I do not get a right angle. That is acute, sorry, that's obtuse, and this angle here is acute. So parallelograms do not have right angles at, do not have diagonals that cross each other at right angles. However, a rhombus, and I'm not going to do a great job here at a rhombus, but a rhombus, if that was a correct rhombus, does have diagonals that meet each other at right angles. Okay, so these two shapes, or the first shape is a trapezium. Now, of course, if you do forget in an exam, you could obviously split that in half and make it into a rectangle and a triangle. But in this case, we want to use our formula correctly. So my formula is area equals half the height, A plus B. Okay, this section here is one section. This section here, the A and B, is another one. They are the two sections that meet each other at the right angles that I keep referring to. Okay, there's my right angle, but in this case, because the 10 and the 15 are different lengths, we add them together, and that whole half thing is part of that. So when I go to work this out, the height is always in between the two parallel sides. There should actually be little arrows there because those two sides are actually parallel. So it's half of the 11 times A plus B, which is 10 plus 15. And then you just work it out. And we get the answer 825 square metres. Okay, so the next one, again, sit back. What do you notice? I notice I have a square, not a rectangle. Okay, I got a square because all sides are equal. I also have inside a a rhombus. The reason it's a rhombus is because all the sides here are equal. Okay, a kite would have two adjacent sides equal, and then these two would be equal but of different lengths. But once again, we don't have that. Okay, so to start doing this, I'm going to go area equals my square, which is 20 by 20, or you can write out 20 squared. And I'm going to minus the white bit, which is my kite, and my kite, of course, is half times the diagonals. Don't forget to add the diagonals together. And notice when I do this, there's no units on this one, so I'm actually just going to write units squared, or I should actually say square units.